So now that we've looked at different ways of solving quadratic equations, let's look at the most efficient method for different equations you may be given. So in all of these, they could all be solved with the quadratic formula, but the quadratic formula may not be the most efficient method. So you can stick with the quadratic formula if you'd like, but sometimes it may be quicker to factor, take the square root, complete the square, or again, just use the quadratic formula. So we are going to look at these equations and determine which is the easiest, most efficient method, and then solve it and graph it. So let's quickly refresh our minds on the different methods. So we have factoring. So if you just have a x squared plus a number times x plus c, if you have a quadratic in this form, you can just figure out what two numbers multiply to get the constant and then add or sum to get the middle terms. And then those two factors are in parentheses, so it'd be like x plus something and then x minus something. That would give us the factors. Complete the square is when you have your x squared and x, the variables on one side, constants on the other. We can take that b number, the number with the x, divide by 2, square it, then we'll get a perfect square trinomial, and then we can solve from there. Or we have the quadratic formula. So if you have a quadratic in this form, you just identify a, b, and c, and plug it in. So let's look at this first problem. So in this first problem, notice it's not in that ax squared plus bx plus c form. It has this quantity being raised to a power. This whole quantity being raised to a power. So this one, it may be easier to solve by square roots. Because we know we can take the square root. So think of this is the same thing as if we'd had like 3x plus 1 equals 13. But instead of x, we have this x minus 4. So the steps to solving for x here would be the same if we were solving for x down here. So first thing we need to do is move over the constant. So we'd subtract 1 on both sides. So we have 3x minus 4 squared. But now we had minus 1, so that's 12. 13 minus 1 is 12. Now we'll divide by 3. Divide by the number in front. So we're left with x minus 4 quantity squared equals 12 over 3 is 4. Well, how do we get rid of or undo a power of 2, this exponent? Well, we take the square root. So we square root both sides. So when we take the square root, notice the square root and the power cancel out. So we're just left with x minus 4 equals, okay, over here we have square root of 4. What does the square root of 4 equal? So the square root of 4, remember when you take square roots, you always get plus minus, and square root of 4 is 2. Now we just need to add that 4 to the other side, so x equals 4 plus or minus 2. So we will get two answers in this case because of the plus minus. So we get 4 plus 2, which is 6, 4 minus 2, which is 2. Those are our two x values in number 1. So notice the next problem is in that ax squared plus bx plus c form. So it might be a little bit easier to solve this by just the quadratic formula. It's equal to 0, so all we need to do is identify the a, the b, and the c. So a is negative 2, b 3, c 4. So now what I want you to do is plug it in and solve. Okay, in number 3, it's not equal to 0. So if you want to use the quadratic formula, you are going to need to move this 9 over to the other side. You could also do completing the square. The only reason I would not recommend completing the square is because of this 3, this b value. Remember, with completing the square, you have to divide it by 2 and then square it. If you do 3 divided by 2 and then square it, you're going to get a decimal or a fraction, and I don't want you to have to deal with that. So I would recommend in this problem using the quadratic formula. So you need to identify A, B, and C. Again, once you move this 9 to the other side, don't identify A, B, and C until your equation is equal to 0. So what is A, B, and C? So A, you should have gotten 1, B, 3, and C, -10. Now plug into the quadratic formula and you'll get your x values. Okay, in the next problem, problem 4, again, quadratic formula will work. You could also complete the square. The reason I would also recommend completing the square on this problem is because of the -4. Because if you divide -4 by 2 and then square it, you will get a whole number. You won't get any fractions or decimals. So it's up to you on which one you want to do. You can either do the quad formula or complete the square. So you can do that one on your own. You can use either method. If you need help, let me know. Next problem. Notice we don't have that form ax squared plus bx plus c. It's just two terms here. Notice they're both perfect squares. 25 and 49 are perfect squares. So this one would be pretty easy to solve by just taking square roots. Moving the 49 over, dividing by 25, taking the square root. So on your own, I want you to take the square root by solving. So add the 49, divide by 25, take the square root. Okay, on 16. Again, we don't see the ax squared plus bx plus c stuff either. So 6 is another example of solving by taking the square root. So you'll need to divide by 16 and then take the square root. Remember, if you get a negative underneath a radical, that means there's an imaginary term. You need to remember that. Negative underneath the radical is an I. So for example, if you got the square root of -100, that really means you have I square root of 100. Well, square root of 100 is a perfect square, so that is 10I. We should put the whole number first, then the imaginary. Okay, last few problems. Let's see which method would be easiest. So on number 7, you could do the quadratic formula if the equation is equal to 0. So you need to get this equal to 0 if you want to use the quadratic formula. You could also maybe complete the square, but I would really recommend in this problem to use quadratic formula. So I want you to identify A, B, and C. So you should have gotten A, B, and C to be 4, -10, and 6. Remember, you had to move that 2 over by doing 8 minus 2. Okay, in number 8, you could do quadratic formula as well. You could complete the square, but you will get some fractions and some decimals. So again, I'd recommend quad formula. So you'll need to identify A, B, and C. Notice, is this equation equal to 0 in number 8? Yes, it is. So you don't have to worry about moving any terms over. You can just say A is 2, B is -10, and then C 12. Plug into your quadratic formula and find your x values. Okay, last few problems. On number 9, notice we don't see that whole ax squared plus bx plus c. You only really see two terms, an x squared and a constant. Anytime you see two terms like this, you will always, the easiest method will be the easiest method will be solving by square roots. So let's solve by square roots here. Because all you'll have to do is move over the 7, divide by 12, and then take the square root. Remember, if you get an imaginary or a negative number underneath the square root, you need to change that negative to the I. Okay, last one. You could do complete the square on this one or quadratic formula, whichever one you prefer. Again, if you do quadratic formula, you need this to be equal to 0, so you'll need to move that over. So I'll let you decide which method you want to do, either quadratic formula or complete the square.